Alright, let's look at the homework 10.3, problem number 10. Alright, use a graph to estimate the y-coordinate of the highest point on the curve, r equals sine of 2 theta. Then use calculus to find the exact value. Alright, so let's do that. Alright, so first I'm going to just use GeoGebra to see what it looks like. Alright. So first, I'm going to define r. So I'm going to call it the function r of x, which is equal to sine of 2x, and hit enter. All right. Let's see. All right. So r of x is defined. All right. So I'm gonna click this circle here to hide that picture. All right. Then we want to sketch the curve. So the curve can be done, just say curve, right? Then here, expression would be r of t times cosine of t, right? Then you have r of t sine of t. Then parameter is t, and let's start from 0. And maybe I'm gonna just do, just in case, maybe I'll just do full pi and hit enter. Alright, so we get this picture. So let's make it a little bit bigger so that we can see this guy a little bit better. Alright, so here. Alright, so that's what we get. Alright. So you can see that the highest point is going to be around here or here. Either way would be fine. Right? So let's find that point. Right? So in order to find the highest point, maybe we should look at the y value and look for the critical number. Right? So let's do that. Alright, so y value is, it's y is going to be, remember that the r times sine of theta, right? So, but in this case, r is sine of 2 theta, so we put the sine of 2 theta times another sine of theta. All right, so we can probably rewrite, all right, then we can rewrite sine of 2 theta as 2 sine of theta times cosine of theta. Then you multiply by another sine, so I'm going to put the square there. All right, so this is a y function, right? So why don't we take the derivative of that? So you have y prime, or maybe I should write it, I should be more specific. Take the derivative of y with respect to theta, right? So this is going to be equal to, I put 2 in front, so actually there's 2 here, so I'll just leave it as it is. Right? Then we're going to take the derivative using a product rule, because you have a couple things multiplied together. So, right? So derivative of sine squared of theta would be, put 2 in front, so you have a sine of theta, right? Chain rule, derivative of sine is cosine, so you have to multiply by cosine of theta, right? And times cosine of theta, so it's a squared, right? Plus, and you have a sine squared of theta times derivative of cosine is negative sine of theta. Right, so maybe I should change that to a bracket here. Alright, then I'm going to factor out what's in common. Looks like, let's say sine of theta is in both terms. So you have a sine of theta here, and then you have a sine of theta there. Alright, so this is going to be equal to, right, 2 is already there. And I'm going to pull out the sine of theta. All right, then what's left is going to be 2 cosine squared of theta minus sine squared of theta. All right, so this is the derivative. All right, then we want to set this guy equal to 0. Alright, then so it looks like this will give us, right, we can make either sine of theta equal to 0, or we can make 2 cosine squared of theta minus sine squared of theta equal to 0. Alright, so let's see, we want to find the angle theta that makes sine equal to 0. So this is going to be like a 0, right? And then pi plus or minus pi, and plus or minus 2 pi, and so on, right? And let's look at the picture again. Would that be the point we're looking for, 0 pi, right? Actually, it's not going to be it, right? So if you look at the highest point here, angle is not going to be a 0 or a pi, so that's not the answer we're looking for. All right, so let's focus on this one. All right, so if you solve this, right, first I'm going to say add sine squared of theta. So you have a 2 cosine squared of theta is equal to sine squared of theta. Right? Then I'm going to say divide through by cosine squared of theta. So you have a 2 is equal to sine squared of theta over cosine squared of theta. Alright, but sine over cosine is tangent, so this is the same thing as tangent squared of theta. Alright, then we can just take the square root of both sides. Then you have a plus or minus square root of 2, and that's equal to a tangent of theta. Right? So this will give us the theta value, right? And so we're looking for the angle. So for example, maybe I should take this picture here. Right, I'm gonna just clip this picture. Alright, so I got the picture in here so that I can draw things. So we're looking for the highest point, which is probably around there. Alright, then if you draw a line segment from the origin, right, this is the angle we're looking for. Alright. So we know that the tangent of the theta is going to be positive square root of 2. So instead of looking for let's see, theta, I'm going to just go ahead and look for tangent of theta, which is equal to square root of 2. Alright. So let's draw a right triangle. So tangent of theta is square root of 2. So think of a right triangle here. All right. Then here. Since tangent is square root of 2, so tangent of theta is square root of 2. So opposite is going to be square root of 2. And adjacent, we can take that to be 1. All right. Then this one, using the Pythagorean theorem, square root of 1 squared plus square root of 2 squared. So this is a square root of 3. All right. So for this theta value, we can actually find the corresponding cosine value and a sine value. So cosine of theta is going to be, right, adjacent over hypotenuse. So it's going to be 1 over square root of 3. All right. And then sine of theta is going to be equal to, all right, so you have opposite, so square root of 2 over and the square root of 3. All right, so let's find the y value. So for that theta, y is going to be the maximum. So y is going to be, all right, it's a 2 times, right, sine squared. So sine squared, sine would be square root of 2 over square root of 3, squared. And a cosine of theta is 1 over square root of 3. All right? So this is going to be, let's see, 2 times, and square that, it's 2 over 3 times 1 over square root of 3. Right? Which means that it's going to be 4 over 3 square root of 3. Right? So this value right here is 4 over 3 square root of 3. Right? So let's type it in. Alright, so we got 4 over 3 square root of 3. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.